Hello, today we're going to be going through some of the basics of trig functions. Depending on where you're at, this will either be an introduction or a quick refresher of where trig functions come from and some ways that we can remember their high-level behavior. To get started, we have this triangle over here on the left, and I've drawn a square in the bottom left corner of this triangle to denote that this angle is equal to 90 degrees. It is what is known as a right angle, and because this triangle contains a right angle, it is what is called a right-angled triangle. Now, for the other two angles in the triangle, I have used the Greek letters alpha and theta to represent them. In this video, we'll mainly be using theta, which is why I've marked it here as a reminder to ourselves. But after the video, you might find it helpful to come back and re-express the results that we get here using the other angle alpha. Now, every triangle obviously has three sides, and the longest of the three sides is what is referred to as the hypotenuse. In right angle triangles, that is. The longest side in a right angle triangle is what is called the hypotenuse. And I'm going to be using short forms just to save some time. The other side that is connected to the angle that we were referring to, but is not the hypotenuse, is what is referred to as the adjacent side, unsurprisingly. Even less surprisingly, the side that is opposite to the angle that we were referring to is called the opposite side. And what the trig functions do is they relate between the angle and the side lengths in the triangle. For instance, if we had sine of theta, it would be equal to the ratio opposite over hypotenuse by definition. And now this angle theta here, remember it's just a dummy variable theta is. So it could be just as easily x, y, z, or even a picture of a dog if you wanted to. It doesn't really matter. Now, similarly, cosine of theta is equal to adjacent over hypotenuse. And the third trig function, tangent of theta, is equal to the sine of theta over cosine of theta. And we can use our relations on the left here to get a ratio of side lengths for tangent of theta by expressing sine as opposite over hypotenuse and cosine as adjacent over hypotenuse. And we can cancel these hypotenuses to get the ratio tangent of theta as opposite over adjacent. And you might be looking at this saying, how am I ever supposed to remember these definitions? There's a way that people commonly remember these, and it's using the phrase SOH CAH TOA. And really, this just writes out these ratios. So we have sine of the angle is equal to opposite over hypotenuse. Cosine of the angle is equal to the adjacent over the hypotenuse. And tangent of the angle is equal to the opposite over the adjacent. And people will sometimes come up with stories and tell these stories as a way to introduce SOH CAH TOA, but I'll spare you from that, and maybe you could come up with your own story about some people you went to high school with or whatever, because we've got more trig stuff to talk about. Specifically, we want to talk about when we know these functions are positive or negative. It's pretty difficult to know the exact values of these functions at any point, except for some standard defined angles, like maybe 90 degrees, 180 degrees, 45 degrees, 30 degrees, like multiples of these eventually you might memorize. But just to be able to tell based on what range the angle is in, whether these trig functions are positive or negative can be really handy. And a way that people remember which of these functions are positive or negative in whatever angle range is they use what's called the cast rule. So in the bottom left here, I have a two-dimensional set of axes with 4 quadrants numbered 1 through 4. And the cast rule basically tells you if an angle is in each quadrant, which of the trig functions, if you were to apply the trig function to that angle, is positive in that quadrant. And it would probably make more sense, say, if I labeled the axes with angles so that you can tell what range each quadrant represents. So we have the first quadrant 0 to 90, second quadrant 90 to 180, third quadrant 180 to 270, and fourth quadrant 270 to 0, or 360 degrees, and then it just repeats after that. So I always had a hard time remembering the cast rule, and I think this is because it starts in the fourth quadrant, which was always really kind of unintuitive to me. I always was never able to remember that it started in the fourth quadrant. So I prefer using the all students take calculus rule instead. And in this A stands for all, which means that all of these trig functions are positive in the first quadrant. So if theta is from 0 to 90 degrees, all of these trig functions will be positive. From 90 to 180, only sine will be positive. Maybe I'll write sine so that we know. In the third quadrant, only tangent will be positive. In the fourth quadrant, only cosine will be positive. Anyways, if you remember that all students take calculus and that corresponds to which trig functions are positive in each of these quadrants, then you should be able to tell at a glance if a trig function will be positive or negative, or a combination of trig functions will be positive or negative for any given angle theta. And I hope that this video has proven to be a valuable introduction or refresher to how you get the trig functions from a right angle triangle and how trig functions relate to a right angle triangle, and how you can tell when trig functions are positive or negative. If you learned something from this video, feel free to give it a thumbs up and head on down and subscribe to the Eng Learning channel. And as always, thanks for watching.